Okay, so we started. Hi everyone, welcome to our session. First, I would like to thank Amdocs for being our gold sponsorship for this event. Next up, we have Brit and Parag from Amdocs, the security team. Brit, it's yours.
Thank you, Ernie. Very excited to talk here today. Today we are gonna talk about providing solutions to the largest telcos in the world, our DevSecOps journey at Amdocs. And specifically, we are gonna talk about our solution for the application security orchestration and correlation, which is wrapping the entire solution and way of implementing. So, sorry. So our agenda for the next 30, 40 minutes would be first to introduce ourselves, of course. We're going to talk a bit about DevOps and DevSecOps. We are going to present Amdocs case and specifically talked, as I mentioned, about the application security orchestration and correlation. And at the end, we are gonna talk about what the solution that we have implemented, which is Defect Dojo, and how we align the open source security into our overall vision. So starting with introducing ourselves. So as I mentioned, my name is Brit Glazer. I'm working in Amdocs for almost 5 years now. I'm currently managing the DevSecOps team. And previously, I was managing all the penetration testing activity in Amdocs. With me today, I have Parag. Parag, you are muted.
My name is Parag, and it's been a 1.5 year with Amdocs. So I am a former Python developer, and now I am a security analyst in Amdocs.
Great. So by the way, everyone, I know that it's a bit different now in Zoom. And everyone are muted. So if you have any questions, please feel free to write them on the chat. I do hope that you'll try to at least save them for the end of the presentation, and we will try our best to answer everything. If not, you can email us or send us a message through LinkedIn, and we will be more than happy to answer and assist. So starting a bit with regards to DevOps. So up until the last few years, development teams usually worked in a waterfall approach, had number of releases spread over the year. Security groups knew how to work in those methods. Every process was spread during certain time frame. There were security gates, which included, among others, security design and the architectural requirements, and of course, the security penetration testing. I'm sure you all know that nowadays, many of those software development companies are working in Agile, which combines DevOps practices, DevOps combines software development practices and IT operations. It intends to reduce the time between committing a change to a specific system and the time that this change is being placed into a normal production, while of course ensuring high quality. As you can see in the diagram, the Agile and DevOps approaches are very common these days and will be even more common in the next few years. So a little bit of numbers, during 2019, almost 50% of the software development companies chose to work in Agile and DevOps mode. And the predictions, according to Gartner, is reaching nearly 70% by 2021, which is really around the corner. Moving forward to DevSecOps, so simple definition would be as written in the deck, an organizational software engineering culture and practice that aims at unifying software development, security, and operations. That means that we are aiming to add security operations and practices into the DevOps approach. Some more statistics that we have from Gartner are that by 2021, DevSecOps practices will be embedded in around 60% of rapid development teams, as opposed to only 20% in 2019. Leading organizations are deploying code as often as every few seconds. From application security point of view, we should integrate security and compliance testing seamlessly into DevSecOps. So the developers will never have to leave their continuous integration or continuous deployment toolchain environments. And in addition, we should make sure that we are providing feedbacks to the developers at an equal pace and as early in the process as possible. Meaning, if in the past, we as the security representatives of the software company use traditional application security processes, focus on providing complete feedback late in the project and via time-consuming gateways, today we must transform and adapt to the new situation, since we simply can't force information security old and heavyweight checkpoint-focused processes on DevOps developers. Instead, we need to integrate continuous security assurance seamlessly throughout the CI/CD toolchain and processes, as mentioned. This means integrating testing ideally on a near real-time basis with the IDE, or as I mentioned, with the CI/CD toolchain. So the security scanning implementation and design should reduce the need for a security professional during the ongoing process. Where possible, everything should be, of course, fully automated and transparent to the developer. So Amdocs in a very high level. So Amdocs is a huge software development and service provider company, which provides solutions for leading players in the communication and media industry spread across its 85 countries. In total, Amdocs has around 25,000 employees, which provide services for 350 different customers worldwide. So indeed, these are a very high number, and we need to make sure that everything that we deliver to our customers is secure. Amdocs rapidly adopted, one second. Just a second. My PowerPoint crashed. Sorry for that. I hope that everyone can see my presentation again.
Yes, we can.
Yes.
Okay.
Okay, great. So Amdocs rapidly adopted the DevOps practices. As of today, 70% of the development teams are working in DevOps mode. Means we had to adapt very fast into this new situation. We are very positive today that most of the participants here already know which application security testing tools you should implement into your CI/CD processes, which plugin you should use, and how you should use it. The main question for us was how we are going to connect it all together automatically. how we are going to support so many different development pipelines and technologies, and how we are going to reduce money spent on security side and showcase a better ROI for our customers. So during our different efforts and POCs, we understood that we need to tailor our own solution and that we cannot rely on a specific vendor to provide us with an end-to-end solution. Therefore, we choose to balance commercial and open source solution together. And we'll present what we did shortly. So here we can see a high-level overview of the DevSecOps security testing implementation within the CI/CD processes. There are multiple testing options we can use. Each one has few main vendors and open source solution. So we have the static application security testing that can be integrated to the IDE or automatically initiated as ad hoc scans. We have the software composition analysis tools to analyze packages for known vulnerable OSS components. We have the dynamic application security testing. We have the interactive application security testing. We even have the container image and runtime scanner. We today would like to focus on the part that connects everything together, the application security orchestration and correlation. Some or all of those solutions, the SaaS, the CA, DAS, it depends on which tools you choose to implement, should run, as mentioned, automatically, identify security issues and gaps automatically, and open security related defects in the developer bug tracking system, such as Jira, BugTrack, or whatever that is being used in your software development company. Ideally, those issues should be clubbed together according to instances in the creation of the issue in the bug tracking system. Results should be aggregated between the different application security testing tools, and defect fixes should be detected automatically. So there are few vendors, I'm not going to remember the names now, but the few vendors providing application security orchestration and correlation solutions, which provide similar capabilities to consolidate and correlate scan data across different scans. For instance, between same application security testing tool, like SaaS to SaaS, that have been run against a given application, aggregate scan data across different application security testing tool types like SAST and to DAST. Another thing is consolidate findings data into one central location, and or for export into bug tracking system. And another item is regrading the findings programmatically based on certain criteria or metadata about a given application, such as what is the business criticality, data sensitivity, exposure or functionality, and stuff around that. The downside we discovering using those solutions are that they are not flexible as we require them to be in many of the situations. So as we mentioned, we have over 70 projects running in parallel. Each one has its own processes, tool sets, and technologies, and we needed to make sure that the output from the different application security testing tools is reaching to the developer's bug tracking system automatically. And we have many different bug tracking systems used in Amdocs. Of course, without overflooding it with security issues, because we simply cannot open, I don't know, 200 or 1,000 security related issue into one product. And also we needed to make sure that the defects that are being opened or the bugs are being opened in a clear way and providing all the needed information for the developer to actually handle the issue. And we needed to make sure that if a fix is being implemented, the bug will be closed in an automatic way for all the application security tools that we are implementing. Adding on top of that, we also needed to make sure that neither one of those 70 plus projects will not disable at any time, any given time, accidentally our security related jobs, and that the jobs are running on every build. Due to those reasons and other reasons, I also mentioned the money related value. Our key success factor in our ongoing DevSecOps journey at Amdocs is the application security orchestration and correlation tool, and the adjustment we did for the Defect Dojo, which is the tool that we chose to use, which is an open source. We added a few capabilities to it, and we are planning to add a lot more in order to support our special cases and needs during our DevSecOps journey. So now we would like to showcase our added extension to the tool. So we prepared a short video. So I'll stop sharing and share the video. Sorry for that. Please just let me know that you can see the video screen. Great.
Yeah.
Awesome. Okay, so out of the box, Defect Dojo provides pre-configured capabilities to connect to Jira, meaning saving the link to Jira, username, and password. So we use in Amdocs heavily Jira and QC, and we have other defect tracking systems as well. So we added the same capabilities to the QC, as you can see on the screen. Our important addition is the default profile that you are now seeing for Jira and QC both. Which is intended to also save the different fields and of course the mandatory fields, which are required to open a security defect or bug in the system. Every default profile connects to the pre-configured Jira or QC that we presented in the beginning. So here you can see all the different fields that we have in our specific Jira that we've connected to. And you can see that we have to fill and populate all the mandatory fields, or else we can submit in order for it to actually work automatically and without any interference. So now, showing it to the, taking it to the QC default profile, which is basically the same capabilities, only to QC. So we are writing the name, connected it to the QC configuration, and we will add the default fields that are needed. So I'll jump forward a bit. Okay, great. After we finish setting the Jira and QC default profile, we would like to add a new product that we would like to scan. In our example, we downloaded the WebGoat and added its source code into our code repository. We are adding a new product in Defect Dojo. For each product, we are, one second, I'll stop it there. We added the clubbing functionality and the minimum severity to open defect functionality. So clubbing functionality is the merge defects based on CWE, and this is the minimum severity to open defects. This is another functionality that we have added. The clubbing functionality clubs instances with the same security issue per application security testing tool to the same defect in bug tracking system. So for example, if you have, I don't know, 50 instances of SQL injection, they will all be clubbed into one specific defect that will be open automatically in Jira for this example, or for QC in other example. The minimum severity functionality lets you define what is the minimum severity issues it should open in the bug tracking system. So in our example, I'll keep running it, we will start with choosing low. So meaning we want Defect Dojo to open all security related issues that has low and above severity. We connect it to a default profile that we've created and submit. Now we are going to build our WebGoat project through Jenkins. So we are pressing build now. As part of the build, we added a job to perform a SAS scan over the code and push the identified issues to the Defect Dojo. So now it is running. Let's give it 1 second. Okay. Now you can see here the results. High severity results are 23, medium 98, and low are 470 lows. Another functionality that we have added to avoid overflowing the developers with issues is to send an email instead of opening the defect if defect count is bigger than a configurable number. So in our example, we define it to be 50, meaning we would like to, as we expected, we can see those defects here, but instead of them being opened, if they were open, there were a certain icon over here showing what is the defect ID. But since the threshold exceeded the limit, we received an email instead saying that probably we should go and check what is going on there because we have 577 instances that should be handled. And you probably won't want to open this big of a number of defects to your development teams. Now we are gonna change the minimum severity to high and run the build again. So we are gonna go to the settings, going to our minimum severity to open defect, changing it to high, and of course submitting. And running the build again through Jenkins. Okay, so now we should expect to see that in Defect Dojo as well, the defects were open, and obviously see the opening of the defects in Jira. So first we'll go to Defect Dojo, and as you can see, there's a certain icon here showing that the defects were opened. As you can see, few instances are showcasing the same Jira ID defect. Because defects were clubbed as well. So here you can see, though we have 23 issues, we have only 3 defects because everything was clubbed together. So all the SQL instances were clubbed under this specific defect. You can see all the relevant information, the attachment, and same goes to the other 2 defects that were open, client DOM XSS, and so on. Now we would like to showcase the automatic defect closing. We are opening the WebGoat code in our IDE, as you can see here, and we are going to fix the SQL injection issue. So we copy paste a parameterized query. We are not deleting, but we are putting in comment the vulnerable SQL query. This is WebGoat, so it's pretty simple. So this is the parameterized query that should solve the SQL injection issue. And now we are gonna push it to push the fix into our code repository. And of course, we are going to run the build again on the fixed code. So in a second, we can see the number of high severity here. We can see that the number of high severity results reduced from 23 to only 9 instances, meaning indeed our fix worked. And now we are going to go back to Jira, and we can see that the status changed automatically to done, meaning it identified the fix. One second, it identified the fix and automatically changed the status. Now we are going to showcase 2 more capabilities that we have added. First is the one that we started at the beginning, that is to finish the QC automatic defect opening. The second one is the health checker. So here we are building and we created another QC product, and we are building it again now. And now reviewing the health checker until the build will be finished. So the health checker is basically created in order to see that our jobs in Jenkins, for example, actually ran, and that no one disabled them or anything similar to that. So here you can see our WebGoat QC, which is the product that we are now scanning. We've added a certain threshold into the health checker functionality, in which if a certain product was not scanned during a certain time frame, for our example, it's 1 minute, then it should appear here. Obviously, 1 minute makes no sense. You probably want to see that the scan happened during the last day, last hour, or the last week. It's configurable, as mentioned. So now you can see the WebGoat QC. When the build will be finished, you'll see that it will disappear from here, as you can see. And that means that the build was actually finished. So now we can go also to the QC and see the defect that were open. So here you can see those 2 defects that remained, because if you remember, we fixed one of the 3 issues at the beginning. So again, same functionalities as Jira. You can see all the relevant information for all the relevant instances clubbed together in one specific defect, and the developer can go and handle those defects. Going back to our presentation.
Brit, we have some questions from the audience.
Sure, yes. Which tools are used for application security orchestration and correlation? So you're asking which tools we have, I mean, which vendors we have out there that suggest the same capabilities? Is this, I suppose this is the question.
I think so also, yeah.
Yeah, so we have a ThreatFix. We have also another company called Denim DX. We have another company called Vulkan, and those are the main ones which I'm familiar with. Next question is, do you check if the SaaS tool returns false positive results before the developers fix the vulnerable code? Yes, of course. So this is why we've created the threshold to begin with. If you remember that we showcased that that if a certain amount of instances exceed of a certain number, then we don't open those defects in the bug tracking system, and we open them in the and we send an email instead. This is because we want to avoid opening so many false positive results at the end of the day, because we want to make sure that what the developer are reaching to and actually handling are actually the right things, and they should take it very seriously and not fooling around with false positives all day long. Okay, any other questions, guys?
That's it for now, I think.
Great. So sorry again. Hope you can see my screen. Yes, Ernie?
Yeah,
Check
it's okay.
every time. Okay, great. So our next steps would be, first of all, we would like to contribute our additions to the community. We hope some of you will be able to use the stuff that we just showcased, and that it will solve some of the issues that you might currently experience while implementing the DevSecOps. And also we soon plan to start and working on a parser for image scanning tools. And obviously once it will be done, we would also like to contribute this part. So last but not least, we would like to thank, first of all, to the Defect Dojo community and contributors, to the guys that are maintaining it. So a big thank you. And for our team members, which helped in every step of the process and development. So thank you, a big thank you, Masha, Samrat, Liora, and Nirmal. It's, as I mentioned, it was a team effort. And now, guys, if you have any question, I know that you ask those, but if you have any other question, you can feel free to ask. And if you have any further question or specific things that you don't want to maybe raise now, you can feel free to email us or send us any message in LinkedIn. By the way, I don't think we mentioned it, but Parag was the main developer for those extensions. So he's here and will be able to answer more of a technical perspective related question for the actual development of those extensions, if you have any. Awesome. So thank you, everyone.
Thank you, Brit. Thank you, Parag, for this insightful training and session.
You're welcome. Okay, everyone.
Welcome.
Yannick, can you please transfer course to me?
Yes, I'm going to stop the recording also, just a second.